Hello dear students, so in today's class we are discussing about the nature of matter. Okay, so in previous class already we started this topic and we discussing the some introduction part. So today we started the nature of matter. Okay, so we first see what are the matter. So do you know students, matter means anything which can occupy the space and they have some specific volume. Okay, so for example, if you take the any example like a pen, pencil, book or living thing, any living thing you can take, all have the matter. Suppose this chalk now, so this is also one of the matter. So it has some volume, it have the some it can occupy the some space. So this board just I am writing here, so this is also one of the matter. So everything, okay, what I say, anything which can occupy the space and they have some volume are the matter. Okay, so these matters are mainly classified into three categories. Okay, solid, liquid and gases. Okay, so these matters are classified into three categories. One is the solid, another one is the liquid and third one is the gaseous. Okay, so see, in case of the solid, do you know students, so any solid example you can take. So all molecules are very close together. Okay, so these molecules are very close together. Okay, so this in case of the solid, so molecules are very compactly arranged, they are very close together. Okay, and because of that reason there is a no movement in case of the any solid. Suppose this chalk is also best example of solid. Okay, so because all molecules are combined together, they are very closed. Okay, you can take the example of stones and any. Okay, so these are the solid in case of the solid. So in case of the liquid, so you can take the example of water. So what happens students, instead of the liquid, so molecules are away from each other, so the distance of the molecule like this. Okay, so they are away from each others, and because of that, so they can easily move. Okay, their movement takes place. So in case of the gaseous molecule, so do you know molecules are far away from each other. Okay, like this. So they are far away from each others. Okay, and because of that reason, so they can easily movable. Okay, so gaseous molecule, so solid molecules are very compactly arranged, they are very near together. Okay, and they are in fashionable order. Okay, and because of that reasons, so they are very strong. Okay, solid. And in case of the liquid, molecules are away from each others, and because of that reason they can easily move from one place to another place. Okay, we can easily move the liquid from one place to another place through the pipes. Okay, in case of the gaseous, so these molecules are very far away from each others. Okay, we'll see what happened when so this solid, liquid and gases, in case of this matter, if you apply the pressure and if you apply the temperature. Okay, see students, so they can interconvertible. Okay, so they are undergoes different changes. Suppose if you take any solid molecules, solid means just we'll take the example of solid like a ice. Okay, solid, we can take the example of ice. So when we can heat, so this is a interconvertible process, this is a reversible process. When this solid means ice, when you have to heat, do you know when ice we can heat, generally it convert into solid, we can heat into convert into the liquid. Okay, so again that liquid we have to heat, so it convert into the gaseous state. Okay, after heating, so this is a actually reversible process. Solid means if you take the ice, next example of ice. Okay, so here ice, if you heat, okay, if you apply the some temperature, so what happens students, so that ice going to be melt. Okay, before that in ice, if in solid state, molecules are very closed. Okay, after heating, so that molecules goes away from each others. Okay, and they convert into the liquid, means it convert into the water state. Okay, again that water, if you heat, again the molecules goes far away from each others, so means they are gaseous, means it is in vapor state. Yes, it is in vapor state. Understand, they are in vapor state. Okay students, so again when this gaseous molecule, if you cool, okay, so it undergoes condensation. So if you cool this, so after cooling, that gases again convert into liquid. Okay, so this is very simple. Again that liquid we have to cool. After cooling this liquid also, so that liquid again interconvertible into solid. Means liquid means water, if you kept in a fridge, so obviously what happened, so we will get ice again. So this is a reversible process. So this is reversible arrow. Okay, so this is a forward direction and this is a backward direction. When solid, we have to heat, it convert into liquid. Again that liquid we have to heat, it convert into gases, means vapor state. Again that vapors we can condensed, means we have to cool, it convert into the liquid. And again that liquid we have to cool, it convert into the solid, means ice. So this is the interconvergible changes takes place in case of this matter, means solid, liquid and gases. These are the three states of matter. Okay, so one more states of matter, that is a plasma. Already you know that. Okay, so now we'll discuss what are the characteristic features of these three states of matter. Okay, so if you see the example of solid, so solid molecules have the definite shape and definite volume. Okay, you know that. Okay, if you take any example of solid, so in case of the solid they have the definite shape and definite volume. Okay, but in case of the liquid, if you take the example of any liquid, you can take a water. So liquid have the definite shape, definite volume, but they do not have the definite shape, means they can acquire the shape in which we can keep that liquid. Suppose if you kept the liquid in any one glass, so they can acquire the shape of that glass. Okay, if you pour that water in the one bottle, okay, so they can acquire the shape of that bottle. Okay, and if you kept in small beaker, so they can acquire the shape of that small beaker, means so they do not have the definite shape, but they have the definite volume. Liquid have the definite volume, but they do not have the definite shape. Understand, students? So in case of the gaseous molecule, so they neither have the definite shape and nor the definite volume also. Okay, so they can occupy the entire space in which we can keep that gaseous molecule. Suppose if I release the gas in that room, so what happened already, so that gaseous molecules goes anywhere in that room, means they are not going to any particular place. Okay, so they can occupy the entire space of this room or anywhere if you pour that gaseous molecule. Okay, so that gaseous molecule can acquire the entire space in which we can keep this gaseous molecule. Now clear, students? If you take the nitrogen gas, oxygen gas, carbon dioxide gas, so they do not occupy the only specific space, they occupy the entire space. Understand? So that is the gaseous molecule, and these are the characteristic features of these three states of matter. Okay, so now we'll discuss the classification of matter. So that is very important. Matters, okay, generally these matters are classified into mainly three categories. Okay, matters. So these matters are mainly classified into three categories. So first one is the mixture. Okay, so first category, that is a mixture. Okay, students, so this matter can be classified into can be divided into two main categories. One is a mixture, another one is a pure substance. Pure substance. Okay, students, so these are divided into two categories. One is a mixture and one is a pure substance. So again, this mixture can be further divided into two types. One is a homogeneous mixture, homogeneous mixture. Okay, and second one is this is a heterogeneous mixture. Heterogeneous mixture. Okay, so these mixtures are mainly classified into two categories. One is a homogeneous, another one is the heterogeneous. And this pure substance again classified into two categories. One is the element, and second one is the compound. Okay, students, so these matters are mainly classified into two categories. One is a mixture and second one is the pure substances. Okay, let you see what is a mixture. Okay, so mixture, there is a combination of two or more chemical compound. For example, sugar solution, okay, sodium chloride solution, or any you can take. Okay, so mixture means there is a mixing of two or more chemical compounds. Like a tea, also one of the mixture. Okay, in tea, so there is a constituted of sugar, tea powder and water. That is also mixture. Okay, so mixture means more than two compounds should be mixed together. Okay, so in your day-to-day life you can see the so many example of mixtures. so which contain the more than two compounds, so they can be combined together. So glucose solution also one of the mixture because it contain the water and glucose. Okay, sodium salt, okay, sodium chloride solution, so that is also mixture. Okay, mixture means there is a combination of two or more chemical compounds. So and pure substance means what? So which contain the the pure substance which have the only one particles and which is completely pure form. For example, if you take and their ratio is fixed, so that is very important. In pure substance the ratio of the element is fixed, so it never change. Okay, so we can obtain or we can extract that compounds from any methods. So the source of origin is any method, whether it is prepared from different resources like a natural, artificial. The ratio of that element should be fixed. For example, if you take the example of water, okay, H2O. So this is a pure H2O. So it have the two hydrogen and one oxygen. So that is a pure substance. Okay, if you take the example of gold, okay, then iron. So these are the pure substance. Then silver. Okay, so there is a no mixture. So in case of the gold also, so that is a pure. Okay, so pure substance, the ratio is fixed. Get it? So again, that pure substance are classified into two categories. One is the element and another one is the compound. Element means which have the single particles. Okay, for example, if you take the example of iron, Fe, carbon, nitrogen. Okay, so then we can take the example of chlorine, okay, zinc, Zn. So okay, these are the elements. So these elements have the single particles. Get it? And what in case of the compound? Compound, there is a combination of two or more elements. So for example, water is also one of a compound, H2O. Then sugar, C6H12O6. So this is also compound, C6H12O6, that is a glucose molecule, that is also one of the compound. Ammonia, NH3, this is also one of the compound. So it having the nitrogen and 3 hydrogens. So ammonia also one of the compound. So compound means there is a combination of more than two elements. Okay, so that ratio should be changed. So that is a compound. We can take the any compound molecule, any compounds like water, ammonia, glucose solutions. So you can take the carbohydrates, anyone. Okay, so they having the different groups. Like in case of the ammonia, so there is a 1 nitrogen and 3 hydrogens. Okay, so if you take the example compound of sulfuric acid, H2SO4. So in this H2SO4 there is a 2 hydrogen, 1 sulfur and 4 oxygen. Okay, that is one of the compound. Now clear everybody? So these matters are mainly classified into two categories. One is a mixture and another one is a pure substance. So in case of the mixture, so already I am discussing mixture means there is a combination of more than two compounds. Okay, so that is a glucose solution, that is also best example of mixture. So here these mixtures are classified into two categories. So this is very important, homogeneous mixture and heterogeneous mixture. So yes students, homogeneous, homo means same, homo means what? Same, and geneous means what? Type, same type. Okay, homogeneous means there is a combination of same type. For example, if you take the example of milk, best example you can take milk. Okay, so so in milk, so that is a homogeneous mixture. Or you can take the water plus sugar, so that is a homogeneous mixture, means they are completely miscible, they are completely mixed together, that is a homogeneous mixture. So in case of the heterogeneous, if you take an example of water plus oil, okay, water plus oil, so this is a heterogeneous example. Okay, so in one glass if you take the water and in that you can add the oil, so what happen? So the water will be fluid on the surface of water, so that means it is a heterogeneous. Hetero means different, hetero means what? Different. Okay, you remember students, hetero different and geneous means type. So different types, so they are not completely mixed. Okay, so they are not a homogeneous, so that is a heterogeneous mixture. Heterogeneous means they are not uniform throughout the system. Clear? So if you take the example of water plus oil, we'll get the two distinct layer, so we cannot get the single layer. So in case of the homogeneous mixture, we'll get one single layer. Okay, so that is a homogeneous mixture. Okay, suppose if you take the water and in that if you add a ink, so then also we'll get a homogeneous mixture. S, so that is uniformly throughout the same layer, so we cannot get the two layers like a water and oil. So in case of the water, we'll get the two layers, so that is a heterogeneous. So if you take the example of water plus alcohol, that is also best example. Water plus ethanol means ethyl alcohol. Okay, so this is also best example of homogeneous mixture. So because they are completely mixed, they are the homogeneous, and they can uniform throughout the they can form the single layer. Okay, and they are the homogeneous mixtures. So they form the completely soluble in the water and alcohols. So that is a homogeneous. And in case of the heterogeneous, they are not uniform throughout the system, means they can form the two different layers. Now clear, students? So this is about the heterogeneous and homogeneous mixture. So in next class we are discussing the another important concept from this topic. Okay, so you can take a screenshot and write down the notes. Okay, students, so you just take a screenshot.